Welcome to lesson 4, example number 2. And it is asking us, it says, for the beam of example number 1, select the most economical steel beam if its compression, which is its top flange, is laterally supported only at its ends and at the midspan. And the way you want to look at this is, for instance, let's assume we have a bridge. And you want to say, okay, well, you have two beams here, and it's only going to be supported from buckling at the midspan. So let's say you have some sort of, let's just say you have something that's bracing that top flange at the, let's say you have some sort of diaphragm where it's bracing that top flange, and it's connected here. And it's bracing it at the midpoint only. So here's your, and looking at a plan view, here are your two beams. Here's your bearing. It's bearing right here. Let's say that's the center line bearing. And then you have the diaphragm right here, which is connected. It's connecting the webs here, which I hope you're understanding what I'm writing. So it's only, and this is what? It says at the midspan, so it's 12 foot. It has a diaphragm or something. It doesn't really say what it is. Something that's bracing the beam. All right, so the question is, where do we go from here? And your number one thing you want to say is, okay, well, the unbraced length, let's call it LB equals what? What is your unbraced length? And we said, oh, it's at brace at the midspan, so we simple do that, or you just say, hey, it's 12 foot. And typically, you want to take that and you want to use these in your steel book, they have these graphs, let's call them, that has unbraced length and then allowable moment. And you go in there and you figure out, you use that graph, and you can see it on page 69 of the study guide. They took that from the AISC books and they went up, and you can see. So we have an unbraced length of 12. So we want to use that. This is unbraced length. And remember, last example number 1, it was continually braced, so we didn't have to worry about buckling. This has everything to do with buckling. And we want to go in and say that on page 69, just use that one. You have 12, and then you go up until you get to 144 on the graph, because remember, 144, and this is in kip foot, or foot kips, and 144,000, I'll just go ahead and do it. Well, actually, it just equals 144 foot kips. And I hope you see that 1,000 pounds. So you take this and you say, I want to get rid of pounds. So you take pounds on the bottom equals 1 kip. And you divide by 1,000 pounds. Whoops. Let's get that back up there. There we go. So you take it and divide it by 1,000 pounds. And you get 144. So you go up on the graph, 144, and you can see that they did it. And then you go to the right, and the most economical beam is going to be not the dashed lines, but the first solid line you come to will be what you want to go ahead and use. And that is, looks like a W16 by 50. And that is the first solid line you come to. And if it were, let's say you had an unbraced length of 14, you go up 14, it looks like it's past 12, of course. And that would be a W18 by 55, but we're not there. We're at 12, so it's a W16 by 50. And let's compare this to what we used last time. And when it's braced continually, we used I'm going to go back real quick and see. We used a W21 by 44, I believe. Yes, 21 by 44. So you see that we actually had to use a less economical beam. And you want to assume that your the more, this is what it weighs. I don't know if you guys knew that already, but this is typically the kind of the height, and this is the weight. And this is not, it's never going to be exactly, well, it might be exactly, but it's around 16 inches. It might be 16.1 inches or whatnot, or a little bit less. That's is actually based on all these 16s are going to have the same T dimension. And go ahead and look in your section properties in your steel book, you'll see that all the same W16s have the same T dimension, which is kind of the height of your web. And this is your weight, which is in pounds. So pounds per foot actually. So it's 50 pounds per foot. This, what we used before, was 44 pounds per foot. So this is actually a cheaper beam because it's less steel. I hope that makes sense. Less amount of material, the cheaper it's going to be, and that's going to be your assumption. So we had to actually bump it up, even though it's a shorter beam. It does weigh more. So, and that is as simple as that as can be. And we can probably go back over here and say, hey, you know, if we have, actually it's continuously supported, we could go to 0, go up to 144, on the chart again, go to 0, go up to 144, and you'll still get W21 by 44. So go up, do the same, I hope you understand what I'm saying. Go to the unbraced length and use 0, which the negative, it goes down to what? 4, I think it is. So use 4, see what it comes up with. Go up to 144 because we had the same moment. Go to the right and you see it has W21 by 44 is the first solid line you come to. And that is the most economical beam at that point. So you could actually use this graph for both types. You could say, hey, I can look at an unbraced length of where it's continually braced, or I can go to whatever unbraced length it is. So let's also, I have a few more minutes, let's take a look at what would this be if you had no diaphragm. There is no diaphragm right here. You have an unbraced length of 24 foot, which isn't really that huge at all. 24 foot, we go to 24 on the unbraced length, so we have equals 24 foot. We go over 24 foot. You go up. Sometimes it's hard to follow these things. And you go up to 144, and it looks like a W14 by 61 is your most economical. W14 by 61. So you have to take a look at it. It depends on what type of situation you're in. This actually might be cheaper to not put a diaphragm in the middle. To say, hey, let's just bump it up. It's 11 pounds per foot more. We're only doing 24 foot, so that's what? 11 pounds times 24 foot. Let's say if you only have 2 beams, that's 528 pounds of steel. Or you could go in here and you say, okay, well, we only have 2 beams. Let's say it has an overhang. So this is your, it's like this, let's say, and you only have 2 beams. And you can go in there and say, well, you know what? Let's just make these W14 by 61s instead of making them 16 by 50s and then having to put the labor in and the connection bolts and all that other things that go into this diaphragm or the system. Assuming, once again, I'm assuming you have a steel diaphragm in between. So this is like a wide flange section that's bolted to these other beams, which these are our beams. And this is our diaphragm. So it's all based on how you want to design it. But given this problem, this is what they asked us to do. Assuming it was braced halfway, we did it, and the answer is a W16 by 50. All right, thanks, and I'll see you on the next video.